let me show you real working examples of real systems that can adapt to changing business requirements. I already showed you the foundation of one a little bit, which was the medical domain. So in the medical domain, I showed that they had all different types of people that they might be capturing different types of medical observations for. And so to extend that, to show you a more complicated one, is in our system really had tons of other values besides people we're capturing. For example, for different types of people, which I showed you through the party and accountability patterns that Fowler talked about to represent types of people, all these different types of people we're capturing medical observations for, like eye color, hair color, weight at birth, gestation age, feeding type, are they going to be bottle fed or breastfed? It could be how long was it? How long was the gestation age before? Was it 9 months, or was it 8 months before birth that the mother carried the infant? Stuff like that. There could be like blood pressure, different blood results. So really, there was literally hundreds of these different types of objects in our system. And so our first model for representing that, if you do the object-oriented way, is we had a class structure for observations. And there was really two main types of observations. Either you're taking a physical measurement, such as some numeric value, and it's got a quantity like a unit, like blood pressure. How many millimeters of mercury, over what? 110 over 80. Or cholesterol level. Or it might be weight, this many pounds, and you want to convert to grams because you're in another country. Or you might be in grams, you want to convert to pounds because you're in the U.S. or whatever. So really you have these types of objects, or you have traits, what we call discrete set of values. Things like eye color, hair color, vision, gender, what's your sex, male, female. And surprisingly, it's not just male or female. When you give birth, it could be XXY or XYY or XXYY. So a lot of times I didn't know all this till I worked on this system, but it's not as simple as just being MF or unknown, right? There's all kinds of variances in between. So really, this really grew quite a bit, we found out. And so our system, this system was a static system. And so whenever what do you have to do? What happens whenever a new observation is required? Or a change to, all of a sudden we find a new type of gender. What do we have to do with this system? Rebuild it. Write new code. Go in there. Okay, we know how to do that. We're good developers. We know how to write code. Fine. Give me Eclipse or my Smalltalk browser or Emacs with my C++ or whatever, and let me hack in there and save it and compile it and release it. But this isn't very adaptable. And so what we did is we kind of started off saying, well, people, we can break this down and simplify it using some of these well-known patterns. Observations are really a property of people. So we can use the properties pattern, dynamic properties. People can have, and I'm not showing here, there should be a star. A person can have many observations. And as we saw by our previous model, there's really two types of observations. And the type is either measurement, we're measuring those quantity values, or discrete values, right? So these are really the two types of possible observations. And we might want to give them a name, such as a phenomenon we're measuring. Like, are we measuring, do they have HIV or not? Or is there a blood test or whatever? So there might be, we can use type object here to kind of set up the name. So as we have this gives us a way of building up new types of observations. So you can think, for example, with John. Remember John, who had Sue as a mother? We might want to capture a couple observations, like John is 3 feet high and have blue. I guess if I had really made this for Brazil, I would have changed those two rather than feet, right? Yes. But let's look at an instance diagram for this. Since I'm from the U.S., I guess I got to use feet. But the nice thing about these quantity objects is they can convert too, right? So if we want to convert to meters or centimeters or whatever, we can easily do that with these objects. So here we have Sue, and Sue has a hash table of the set of possible observations that we can hold on to John. Here we have John, and John has a collection of its properties, which are the observations. And so one observation of John is a measurement, which is height. That's why you use the type, so it has the name and stuff, and any other things about the type. And it has its actual values, 3 feet. And similarly, John has a trait, which is a discrete value, that can hold on a set of eye color. It has the eye color, and it's just holding on to its value of eye color. Okay, so now we can define new types of observations in our system. However, observations in general are more complex than just this simple design. For example, cholesterol is HDL over an LDL. These two values have to work together to make your cholesterol. In blood pressure, we always say systolic over diastolic, and there's rules associated with blood pressure that the systolic has to be greater than the diastolic unless you're dead. And they both better be greater than 0 unless you're dead. You know, and they can never be negative, even if you're dead, right? So there's different types of business rules that associate when somebody's entering values that we might want to ensure integrity constraints on this system, business rules. And so really, observations can be more complex and we might want to compose them together, right? And so what we can do is we can apply a well-known design pattern called the composite pattern to extend our original design that now can have more complex observations by building them up from these primitive observations. So we still have our measurements and traits, but now I can build up cholesterol as being HDL and LDL, which happens to be 2 primitive measurement observations. And so cholesterol is a more complex observations. And so a person can still have these observations and cholesterol happens to be composed of 2 other observations. Okay? And that's doing the composite. You know, I like you see the composite a lot, so people are used to it usually. Composite's the OO way of having a dynamic tree. And so here we can have a dynamic tree of our observations that we can compose and build together dynamically. So here's an example again. Let's add a new observation to Johnny. We're going to take his blood pressure, which is 120 millimeters of mercury over 80. And so when we look at John, his blood pressure observation happens to contain some children, right? That's the composite pattern, is you're composed of sub-pieces possibly till you get down to the leaf nodes. And so the 2 leaf nodes happen to be 2 measurements. One is 120, which I'm simplifying by just putting the value here rather than showing it to a quantity object. It would really gone to a quantity object, right? And then over 80, okay? Sometimes you have to simplify your diagrams to make them easier, so that's what I've done there. And so this is a way of, now we have a way of dynamically building up more complex observations. So really, what do we know about John? Now we can, John, who's, you know, a person, we can capture all kinds of dynamic properties. And if our system needed new things to capture about Johnny, we can store it into a database, the types of properties with the types of observations that it is, and whether it's composed or primitive, and what it's, you know, what it is, what kind of value. Is it a measurement or is it a trait? However, each observation also we want to be able to validate, and I haven't said anything about validating. For example, a baby's weight, I alluded to that if there's any substance there at all, better be greater than 0, right? You know, maybe this should actually be not the square bracket, but the curved bracket, right? And you have to be greater than 0. And if you give birth to somebody, I think the Guinness Book of World Records, is bigger than 30 pounds. It's a pretty heavy baby. That would be a very painful mother if anything happened like that. So, and then what's like hepatitis B? You'll have things like positive, negative, maybe unknown is another value, possibly. So you also have these types of legal values that you can take. And so we can put the legal values in a GUI, but that breaks every rule we learned about good design. We want to separate the presentation layer from our business or our domain layer. You know, and so we have this nice, what they call 3-tier or N-tiered architecture nowadays. Let's keep a lot of these things separated. So let's not put our business rules into the GUI. And so what we did was we applied the strategy pattern to our types of observations, and so they were able to validate what are the legal set of values that you can enter in. And in fact, our GUIs could become dynamic because they could use these values for building up the GUIs. Similarly,